NASA's James Webb Space Telescope, scheduled for launch in 2019, will probe the cosmos to uncover the history of the universe from the Big Bang to alien planet formation and beyond. It will focus on four main areas: first light in the universe, assembly of galaxies in the early universe, birth of stars and protoplanetary systems, and planets, including the origins of life. The James Webb Space Telescope (JWST) will launch on an Ariane 5 rocket from French Guiana, then take 30 days to fly 1,000,000 miles to its permanent home Lagrange point, or a gravitationally stable location in space. It will orbit around L2, a spot in space near Earth that lies opposite from the Sun. This has been a popular spot for several other space telescopes, including the Herschel Space Telescope and the Planck Space Observatory. The powerful $8.8 billion spacecraft is also expected to take amazing photos of celestial objects like its predecessor, the Hubble Space Telescope. Luckily for astronomers, the Hubble Space Telescope remains in good health, and it's probable that the two telescopes will work together for JWST's first years. JWST will also look at exoplanets that the Kepler Space Telescope found, or follow up on real-time observations from ground space telescopes. JWST's science mandate is principally divided among four areas: first light and Reionization. This refers to the early stages of the universe after the Big Bang started the universe as we know it today. In the first stages after the Big Bang, the universe was a sea of particles such as electrons, protons and neutrons, and light was not visible until the universe cooled enough for these particles to begin combining. Another thing JWST will study is what happened after the first stars formed. This era is called the epoch of Reionization because it refers to when neutral hydrogen was reionized, made to have an electric charge again by radiation from these first stars. Assembly of galaxies. Looking at galaxies is a useful way to see how matter is organized on gigantic scales, which in turn gives us hints as to how the universe evolved. The spiral and elliptical galaxies we see today actually evolved from different shapes over billions of years, and one of JWST's goals is to look back at the earliest galaxies to better understand that evolution. Scientists are also trying to figure out how we got the variety of galaxies that are visible today, and the current ways that galaxies form and assemble. Birth of stars and protoplanetary systems. The Eagle Nebula's pillars of creation are some of the most famous birthplaces for stars. Stars come to be in clouds of gas, and as the stars grow, the radiation pressure they exert blows away the cocooning gas, which could be used again for other stars, if not too widely dispersed. However, it's difficult to see inside the gas. JWST's infrared eyes will be able to look at sources of heat, including stars that are being born in these cocoons. Planets and origins of life. The last decade has seen vast numbers of exoplanets discovered, including with NASA's planet-seeking Kepler Space Telescope. JWST's powerful sensors will be able to peer at these planets in more depth, including in some cases imaging their atmospheres. Understanding the atmospheres and the formation conditions for planets could help scientists better predict if certain planets are habitable or not. The JWST will come equipped with 4 science instruments. Near-infrared camera NIRCam provided by the University of Arizona. This infrared camera will detect light from stars in nearby galaxies and stars within the Milky Way. It will also search for light from stars and galaxies that formed early in the universe's life. NIRCam will be outfitted with coronagraphs that can block a bright object's light, making dimmer objects near those stars like planets visible. Near-infrared spectrograph NIRSpec will observe 100 objects simultaneously, searching for the first galaxies that formed after the Big Bang. NIRSpec was provided by the European Space Agency with help from NASA's Goddard Space Flight Center. Mid-infrared instrument MIRI will produce amazing space photos of distant celestial objects, following in Hubble's tradition of astrophotography. The spectrograph that is a part of the instrument will allow scientists to gather more physical details about distant objects in the universe. MIRI will detect distant galaxies, faint comets, forming stars and objects in the Kuiper Belt. MIRI was built by the European Consortium with the European Space Agency and NASA's Jet Propulsion Laboratory. Fine guidance sensor near-infrared imager and slitless spectrograph FGS-NIRISS. This Canadian Space Agency-built instrument is more like 2 instruments in one. The FGS component is responsible for keeping the JWST pointed in exactly the right direction during its science investigations. NIRISS will scope out the cosmos to find signatures of the first light in the universe and seek out and characterize alien planets. The telescope will also sport a tennis court-sized sunshield and a 21.3-foot (6.5 meters) mirror, the largest mirror ever launched into space. those components will not fit into the rocket launching the JWST, so both will unfurl once the telescope is in space. Credit Carl Tate, Space.com infographics artist. JWST has a long development history. It went over budget and affected NASA's astronomical funds, which among other things, caused the agency to pull out of some joint missions with the European Space Agency. Even while Hubble was being prepared for its space mission, a successor telescope was being planned that would improve on Hubble's capabilities. After early-stage studies in the 1990s, NASA embarked on a faster, better, cheaper era that was intended to use electronics miniaturization and Tiger teams to reduce the cost of space missions. This caused a reformulation of these early telescope studies into something called the Next Generation Space Telescope, which was then pursued well into the 2000s. The first version of NGST called for an 8-meter aperture and for the telescope to be flown to L2. NGST was renamed the James Webb Space Telescope in 2002, after a former NASA administrator. The project was estimated to cost $4.5 billion in about 2005, but cost overruns occurred in the years following. In 2010, an independent review panel for JWST warned that the telescope would be substantially over budget. The panel noted that following a NASA confirmation review in 2008, cost growth and schedule delays were associated with budgeting and program management, not technical performance. Among the problems the review cited were poor estimation procedures and a baseline budget that was too low. The panel suggested the earliest launch date possible would be 2015. Around 2010, NASA and the European Space Agency were cooperating on several large-scale missions, including ExoMars and a predecessor mission to Athena, an X-ray telescope. By 2011, however, ESA said it would rather go forward on these missions by itself. NASA had cut back on its other astrophysics programs to allow for JWST development, including pulling out of ExoMars. Further, the U.S. National Science Foundation Decadal Survey of 2010, which establishes astronomical programs of priority, had ranked the joint ESA missions lower than other initiatives, ESA said in a statement at the time. By 2011, JWST was slated to cost $8.7 billion, prompting some consideration that the project be cancelled due to overruns. While funding was allowed to continue for the mission, NASA acknowledged that other missions would need to be delayed to account for the budget overruns. Increased vigilance on the program continued for several years, and by 2015, NASA said that the telescope was now on track with its new budget and schedule, which called for a 2018 launch. However, in September, NASA announced the launch had been pushed from October 2018 to the spring of 2019, citing spacecraft integration issues. The change in launch timing is not indicative of hardware or technical performance concerns, Thomas Zurbuchen, Associate Administrator for NASA's Science Mission Directorate at the agency's headquarters in Washington, D.C., said in a statement. Rather, the integration of the various spacecraft elements is taking longer than expected. The JWST is named for former NASA chief James Webb. Webb took charge of the space agency from 1961 to 1968, retiring just a few months before NASA put the first man on the moon. Although Webb's tenure as NASA administrator is most closely associated with the Apollo moon program, he is also considered a leader in space science. Even in a time of great political turmoil, Webb set NASA's science objectives, writing that launching a large space telescope should be a key goal of the space agency. See photos of JWST, Hubble's successor. NASA launched more than 75 space science missions under Webb's guidance. They include missions that studied the Sun, stars and galaxies as well as space directly above Earth's atmosphere. Additional reporting by Miriam Kramer, Space.com staff writer.